Yeah. Okay, bye. Have a good weekend. All right, now, okay. Welcome, everyone. Welcome. We are going to be starting here. Admit some people. Okay, so welcome. I think we will probably be getting a few more people joining in. Hopefully, you should be able to hear me all right. And we are recording. Good. Okay. So let's get started. So thanks for joining, everyone. Hopefully this will work out well. So the way that this is going to work is teachers that are running Zoom, running this in your flex classes, will open up a discussion to students and a Q&A session. Unfortunately, I couldn't find an actual expert, so all you have is me. And when you have questions in your classrooms, please just curate the questions from students. So anyone that has a question, feel free to ask your flex teacher, and the flex teacher can type the question into the chat. Okay. In fact, let me get that pulled up. So let's see here. Can I pull the chat? Let's see here. Chat. Where is the chat? Participants. All right, so I guess underclassmen on the basketball team are going to Miss Johnson's room. All right, so let me see here. You should be able to hear me. We will talk about it, Sam. All right. Okay. No, you're good. All right. I believe that you should be able to hear me, and we are good to go. If there are audio problems, put them in the chat. Okay. Let's get started. So you should be able to see on in the Zoom call. I've just got a picture here of the Rover.
Are you letting us in?
Am I not letting you in?
I don't know.
I should be letting you in. Oh, sorry. Yeah, I just admitted you.
Okay, right. I just didn't know.
Okay, thank you, Mr. Roberts. Sorry, I'm running a bunch of things at the same time. There's Miss Beliach. Okay. Okay. I'm going to try and keep focused on as many things as I can. I'm not a great multitasker. You can ask a lot of people about that, and they'll tell you that that's the truth. So this is the Mars 2020 rover, also called Perseverance. All right. So the question that a lot of people are going to have is, why did we launch this? And we'll go through that. We'll go through when it launched, what the whole purpose of the mission is, and what we hope to learn from it. So this is the Mars 2020 rover, also called Perseverance. It launched in July of last year. It was a pretty cool launch. It launched on a rocket that is really common, but that's not why we're here today. We are here today mostly to talk about the landing that occurred today, which was pretty impressive. So let me just pull up this picture really quick for you so you get an idea. Here's a picture of the launch. This was last year. This is called the Atlas V rocket, launched out of California, actually. Yeah, no, didn't launch out of Florida. Sorry, that was a mistake on my part. So let's talk about the rover. We didn't get to do this live when the rover was landing. The landing attempt happened about 20 minutes ago, but let's talk about the whole process, okay? So the reason why we're doing this today is because of the landing. So we're gonna check out this video of what the landing should look like if everything goes correctly. Oh boy, I have too many tabs open. Okay, so let's check this out. Okay, I think that, yeah, there we go. So let's check this out really quick. What the landing is supposed to look like. So that's today, February 18th, 2021. Let's see how this works, okay? I'm gonna turn the light off actually, so that students in my class can see a little bit better. So this is the rover in its heat shield and aero shield coming forward. The thing that it just dropped right there is the solar panels and power unit. As it approaches the planet, things start getting a little spicy, real spicy. You can see it streaking through the sky there. The surface of the heat shield got to about 2,000 degrees Celsius. So now we are ultra spicy. An interior view of what it would look like inside. A little shaky. So it's using these little thrusters to control its descent. Make sure it's pointed in the right direction. There's a supersonic parachute. And then the whole assembly starts to kind of disassemble so that the rover can land safely as it descends. So the heat shield pops off and goes and makes a big old dent in the surface. And then the rover actually is released by the parachute, and that is called the sky crane. It is a rocket-powered descent vehicle because Mars's atmosphere is not thick enough to use a parachute to land. So the parachute doesn't slow you down enough. So they needed to use this rocket pack. It's essentially like a jet pack for this rover. As it approaches, it searches for a good place to land, and it has this sky crane. And once it touches down, it releases the cables. The sky crane jetpack goes off and makes its own crater in the surface. So pretty cool. The engineers that designed this thing call that the 7 minutes of terror, it's a pretty ingenious landing system. Seems really complex, maybe overly complex, but that's how NASA and the Jet Propulsion Laboratory like to do it. They're a little bit extra that way. So when we were waiting for this to happen today, there was a live stream that occurred, and we were hoping that everything would go off just the way that we want it to go. And here is a look at the headquarters of the rover control team as the landing occurred. So there was a successful landing. Everything said that it looked good. And then, so they were looking at all the data, making sure that everything looked good. And then the announcement came that it was successful. And joy to the nerds, it successfully landed the rover. So we do have a successful landing today. Pretty amazing that everything went the way it was supposed to go. Okay, so we're just gonna leave them to celebrate, but let's check out really quick what actually happened when they landed. So here is the first image from the rover on the surface. Obviously, this is not in color, mostly black and white, right? You can see here the rim of the wheel, the right front wheel. But they turned the cameras on. This is what it could see. There are 3 other images as well, right here. On the side, these are from the other cameras that had been turned on. And you can actually see, I know it's probably really, really small to look at, but there's the shadow of the rover on the surface. So there it is, the surface of Mars, successful landing, pretty sweet, okay? Yeah, Sam, question? Why isn't it in color? So they do have really powerful cameras on here. They use multiple spectra of colors and so forth, but it's actually the best to use the black and white camera just for contrast generally. Okay, let's see here. We've got a question from Miss Goodman's class. Will the rover be coming back to Earth? If so, how long will it take? It will not be coming back to Earth. This rover is going to be staying there. Getting back to Earth from Mars is pretty tough. It took 7 months for it to get there using a very large rocket. It's going to stay there. Mr. Davenport's class has a question. How much fuel does it carry? The rocket or the rover? So the rover, we'll talk about its power system. It has that jetpack that only has a few large fuel tanks. And we'll talk about the size of the rover as well. Video showed us of the landing. This is just a computer simulation. Yeah, so it was just a computer simulation that I showed you of the landing. Unfortunately, we can't have a third-person view from the outside there. Let's see here. Other question. Joy to the nerds, black and white. So yeah, black and white contrast, and just they use multiple spectra. That most of the spectra just look black and white to us. There is no live video of the landing, Mr. Gaji's class. Not yet. They should have some video, but that's really high data requirements, and this is a communication issue between 2 planets that are about 600. Let me think about this. About 190 million kilometers away. Don't quote me on that, but it's really far. It's millions of kilometers. Let's see here. How long is the rover expected to last? So the mission that the Perseverance rover has, they have an expectation that it's going to last a while, but the initial mission is about 90 days. It will probably keep on going for a really, really long time. We'll be looking at a diagram of the rover in just a little bit to look at what different things it's going to be doing. Okay, so I'm going to come back to the question chat in just a second. Let's talk about the rover itself. Okay, so we have the image here of the surface. Let's talk about what the actual rover looks like. All right, so here is a picture of a person standing next to the rover. It's quite large. It's the size of a small SUV. This is the main camera and sensor tower, and then there is an arm that is extended out this way. It's kind of a weird picture. We'll look at some other pictures here though. That has a whole bunch of instruments and so forth on it, okay? So it is a pretty large rover. You can see the wheels here come up to about this guy's knee. Yeah, it has lots of really cool instruments and materials on there. So let's talk about those, all right? So here is the main parts of the rover. They're labeled here. A couple of them are not labeled. We'll talk about that in a little bit. So on the main tower or mast, we have these two cameras right here, these are the cameras that they use most of the time for like steering and looking where they're going. They're binocular, right? So they have two of them, just like our eyes. They use triangulation to detect distance. Okay. So also we have this camera here, which uses a laser micro imager. So that one's going to be very important for getting more information if they want to investigate rocks and so forth, to get more data from those kinds of rocks. They can use spectrometers and so forth in there. Okay. We have a weather station called META. I don't know what exactly that means. Okay, but the weather station has for temperature and wind speed, wind direction, humidity, and air pressure. The surface of Mars is extremely cold. And when I say extremely cold, I mean like on the warmest day, at the very equator of Mars, we're talking about 0 degrees Celsius. Okay, right about freezing. It is cold, all right? So the station's gonna get all that. We have the RIMFAX, which is the subsurface radar. It's this thing right here. So this is gonna be able to use radar that can actually detect materials under the surface for a few meters down, which is pretty sweet. So if they find pockets of different kinds of rock, or I mean even pockets of water and so forth, that would be extremely interesting. This right here is one of my very, very favorite experiments on this. This is called MOXIE. They're going to be producing oxygen, breathable oxygen, from the carbon dioxide on Mars. Mars has a mostly carbon dioxide atmosphere. Even though it's really, really thin, there is pretty much all CO2. And so this is a very important mission for when humans want to go to Mars, because we're going to need something to breathe. And if we can produce use carbon dioxide to produce breathing oxygen, that would be a big deal. Okay. We talked about those. Yep. And then we have the main arm here. Okay. On the arm, there's a drill. There's the ultraviolet spectrometer, which is called Sherlock. And Watson is a camera, like a visible camera that is on the arm. So Sherlock and Watson, hilarious, NASA. We have Pixel, the X-ray spectrometer, that will be looking at some different things. So all of these instruments were chosen for very specific reasons. There are a couple of other instruments on here that I want to talk about as well. This back section is where it has a small nuclear reactor to power the rover. This does not have solar panels. It has a nuclear reactor. It's called an RTG, or radiothermal isotope generator. So it can produce its own power even when the sun gets blocked out by maybe a Martian dust storm or something like that. This also has some materials on it here on the belly that we can't see in this image, that will take samples from the surface and then put them in little tubes to be collected later for a return mission. So NASA is working on sending a small return vehicle, so it would land on Mars, collect all of these samples that Perseverance takes, and then put them in a small rocket and shoot them back to Earth. So that's pretty sweet. And they're going to be using all of these pretty much every day, looking at different things, looking at different data. Perseverance is not exactly a speed demon. Perseverance will probably be moving just a few meters per day, little bit at a time. investigating every little rock and every little crack and every little grain of sand along the way, because there's a lot to learn. So the primary objective is to do some science, but there's also a secondary objective, and let's look at this really quick. This is Ingenuity, the first flying machine that has been sent to another planet. This is a helicopter that is designed to fly on Mars, and it is very cute, and it is very little. It's extremely light, because Mars has essentially no atmosphere. The blades have to spin really, really fast, and this has to be super, super light. Most of this is made out of carbon fiber. But yeah, it should be flying around. It'll do some scouting to see where Perseverance should go. It's got a little solar panel on top here to power it. It's going to be pretty awesome. I'm really, really excited to see some pictures from from Ingenuity. Yeah, question in the room. It's like a little scout craft, yeah. Yeah, like a little scout craft. Okay, let me go to the questions here. What is the torque of the rover's wheels? Well, these are electric motors, obviously. We're not going to be using internal combustion engines there. Electric motors have really high torque. So it's able to climb and go over rocks and climb up mountainsides. Plenty of torque. I couldn't tell you an exact unit, exact number on the torque, but it's plenty. It is plenty. Let's see here. We understand this rover Perseverance is in contact with the other rover Curiosity and a third NASA satellite with the other devices of the planet now. Will Curiosity and Perseverance meet? No, they will not meet, unfortunately. Curiosity and Perseverance are twins. They are built on the same platform. However, Perseverance has been upgraded. The wheels are a little bit better. Curiosity has wheels in it, holes in its wheels now because of sharp Martian rocks that we did not exactly anticipate. But unfortunately, they will never meet because they are essentially on opposite sides of the planet from each other. Well, they're not on opposite sides, but they are a long, long ways away from each other. So far away that these rovers, considering that they only move at a few meters per day, would be really, really, really far for them. And there is, yes, they are in communication with the Mars Reconnaissance Orbiter, or MRO, which is a spacecraft that orbits Mars and is very helpful in relaying data and information from the surface of Mars to us here on Earth. Another question here. Let me see here. Let's see here. Oh, wait, sorry. What is the gravity on Mars, and does anybody control or drive the rover? Those are excellent questions from Mr. Bradshaw's class, or from Mr. Bradshaw, I don't know. The gravity on Mars is about 1/3 of that here on Earth. So whatever you weigh here on Earth, cut that into threes, and just one of those, 1/3 of the weight. So they can make this thing pretty heavy, but the struts and axles and so forth don't have to be strong enough to really work here on Earth, but better to work on Mars. Okay, all right. Does anybody control and / drive the rover? Yes / no. Mr. Bradshaw actually is one of the coaches for the robotics team, right? So this is essentially a robotics team competition. They program every day. They program something for the rover to do. They program something for the rover to do, and then it goes and does it. The problem is that you can't control it in real time, like an RC car or anything like that, because there's a delay. It takes time for the message to get from here to Mars and from Mars back, right? So depending on where the planets are, that can be like 5-6 minutes to one-way trip. or it can be up to 20 minutes for a one-way trip. So you can't control it in real time, but what you can do is you can say, all right, we see in front of us that there's this rock. Let's go over to that rock by moving forward this much, lowering the arm, making contact with the rock, drilling into it, running an analysis. So they pre-program that every single day, and then it goes and does it. And these engineers actually, this is interesting. Mars has a day that is 24 hours and 46 minutes, just a little bit longer than our day. But the engineers that work on these programs actually have to set their clocks to Mars time, because they only run the rover while the sun is up. Okay, and so when they wake up in the morning and so forth, that's essentially all dictated by the Martian day. Okay. Another question: do we know the power of the motor of the rover? Again, so I don't know how much torque there is in the motors. There are individual motors in each of these wheels. I don't know the power or of the generator. I don't know the exact number. I'm sure that this would be able to power your house though. Yeah, let's see here. What do we know? Let's see. Your gravity on Mars is 30% of what we have here on Earth. Yep, smell it. Why does it move so slowly? Well, because of what we were just talking about with everything has to be pre-programmed, right? So just a little bit at a time, do a little bit of science. Because of that communication delay, it can't be like a speed demon on the surface of Mars. What time would it be on Mars? Well, it depends on where you are on Mars, right? This actually is a good segue into where the rover landed, which is a place called Jezero Crater. So Jezero Crater is a place on the surface of Mars that we are pretty confident had water, liquid water. And we'll come back to the reason why that is in just a little bit. Yep, Jezero Crater. So this is where this is. Jezero Crater is this guy right here. This is the approximate landing zone of the rover, and then the planned path for the rover to take. This, right now, Jezero Crater is, I believe, just coming into, it would be really early in the morning at Jezero Crater. So the sun has just risen. Interesting fact for you, sunrises and sunsets on Mars are blue, not red, they are blue. And the sky is pink. So there you go. What are they expecting to see, or what info do they hope to find from the rover? So excellent question, Mr. Kreider's class. We are going to talk about that in just a second. So let me come back to that. Can the rover conduct any analysis of the samples? Yes, they can conduct analysis of the samples using these spectrometers, which are these guys right here, which essentially shoot little samples with lasers and then analyze the light that comes off of it. So they can see what the rock is made out of, what the sample is made out of. They can see any volatiles like water or carbon dioxide that are trapped in there that might evaporate away. And so they can run analysis of the samples in real time. Unfortunately, not as much as like a scientist could do. These rovers take about a week to do the amount of work that a human scientist could do in about an hour. So it's really slow, but it is effective, especially because if you tried to go and take Perseverance's place, you would die a very quick and painful death. Okay, question, are any of the other rovers still active? Yes, Curiosity, Perseverance's twin, is still active, as is a small rover on a Chinese spacecraft. that just landed a few weeks ago. Let's see here. Why is the sky pink on Mars? That has to do with dust, Martian dust in the sky. Yeah, it would be a very, very light pink. But the dust is almost completely iron oxide, which is rust. So that's the reason why the sky is pink. Okay, excellent questions, everyone. So going back to Mr. Kreider's question, which is, what is the main purpose? What are they looking to find in this mission? The main purpose is to look for signs of past life, okay? And the reason why they went to this specific area of the surface of the Earth, or of Mars, not the Earth, is because, again, they are quite confident that it was once a large body of water, okay? Not only was it a body of water, but it had plenty of coast along the body of water, which is where life here on Earth really, really thrives, okay? So this is an artist's rendering of what Jezero crater may have looked like a few billion years in the past. So the Perseverance rover is going to be using all of its instruments to investigate whether or not there may have been life, doing chemical analysis on the rocks, looking at the rocks at different angles and seeing if there's any kind of fossilized bacteria or what are called stromatolites, which are rocks that are made out of the dead bodies of little microscopic organisms. We have a whole bunch of them here on Earth, but we'd like to see if we can find something that is similar on Mars, because Mars used to be a lot nicer. Now it's not so nice. It used to be warmer, it used to have liquid water on the surface, it had a thicker atmosphere. It would have just been a pretty good place to go vacation, but not any longer, all right? So there we go. Yeah. Yeah, Sam.
Is it true that they think that it might have been possible that our first life actually came from like after this?
Yeah, so we've got an in-class question here about a hypothesis called panspermia. Panspermia, which is the hypothesis that life may have actually started on Mars or maybe Venus, and that somewhere along the way, a big old chunk of Mars may have been knocked off by an asteroid impact or something like that, and the little living things were little stowaways on that asteroid, and then that asteroid came and hit the Earth, seeding the Earth with life. So that is a hypothesis. We don't have a lot of evidence to confirm that hypothesis, but yes, it is possible that if we do find signs of life there on Mars, that it would be very, very similar to the life that is currently here on Earth, because it is possible that we might be related. So you and I and every living thing here on Earth might be related to anything that used to live on Mars. It's very unlikely that there's still living things on the surface of Mars, but it's very, very likely that it may have had life in the past. I wouldn't say very likely, but it was more hospitable to life. How about that? Okay, so no more questions quite yet, so that's fine. Let's keep on going here. So on this mission, again, it's going to be investigating to see any further evidence of living things on Mars. We're going to be wrapping up here because we only have about 10 minutes left of school. It's gone by really fast. I appreciate all the questions and everything. Hopefully you've learned something. If you want to get a last question in, please ask your flex teachers, and they can put one into the what do you call it? The chat. That's the word for me. Again, I'm not an expert. I just have an obsession with space, so I'll try and answer any questions that you might have. I do want to, before we finish, just talk a little bit, and anyone that's taken my class knows that I like to share maybe a little bit of inspiration about all of this. I think it's pretty amazing that humanity has been able to send something to the surface of another planet. I would call that an amazing accomplishment. When we talk about the accomplishments of humanity, space travel, I think, has to be way up there. We, an animal species here on the planet Earth, have been able to take the things around us and build tools, and we have sent out these robotic ambassadors that are able to visit these other planets, and that we can accurately send something that we have created here on Earth by humans to another planet and land it safely, to go and look around and see, hey, is there anybody around? Is there anybody like us over here? Can we learn anything from what we see there? How we came to be? Can we learn more about our place in the universe? I think that that's beautiful. And not only do I think it's beautiful, I think that it's very important that we take a moment to appreciate that we're just one little speck in the universe, and that we can explore and find out more about the universe around us. So I appreciate all of you tuning in and listening to my little rant there. All right, last couple of questions. Do we know the programming languages that are used? Oof, no, I don't know the programming language. I'm sure that you can find that information somewhere. It is very, very possible that they might be using their own programming language that's developed at the Jet Propulsion Laboratory, but I do not know what the programming language is. That's an excellent question. Do we think the mission will help us know if we will ever be able to live on Mars? Humans will be able to live on Mars. That is, I don't think that's even a question. Not only will we be able to, we will live on Mars. People will be going to Mars. And the fact that there is an instrument on this mission that is there to produce oxygen on the surface is just a small step in making the technology that we need to live on Mars. We will be there. In just a few years, there will be humans landing on the surface of Mars. That's what's really cool. Yeah, it is kind of bold, Sam, but the thing is that I don't think that it's all that unlikely. Humans are going to Mars, and we're going other places as well.
I don't think that part is bold, but the fact that you think that we're going to go there in a few years.
Yeah, I mean, a few years relative. So let's say a few years. If there's anything like the data and evidence that we can collect recently, there is a lot of evidence that suggests that we will be able to land on Mars. Probably, I'm gonna be really conservative in my estimate here. 2040. I think it's gonna happen by 2032. I think 2032 is going to be, before 2032, we have human beings on the surface of Mars. Last question. How far away is the rover from Opportunity? Excellent question. Opportunity is over here. Perseverance is over here. This is the entire planet. They are way far away from each other, several thousand kilometers. Curiosity is over here, another several thousand kilometers away. So we've got all these different landing sites of NASA rovers and so forth. But yeah, here's where Perseverance is. Successfully landed today. It's a big deal. Be excited, my friends. Humans are doing amazing things. I'm gonna end the call there. Thank you for your questions, everyone. I'll talk to you later. I don't know where my flex class is going.